We're going to talk about weighted average. And so in a weighted average, that means some of your components have more importance or more weight than others. So in order to really understand this, you should first understand how we do a regular average or a mean. So if you don't know how to do a regular average or mean, you need to watch that video on Facebook. Because here we're going to have a weighted average. And all that means is that our components don't actually have the same importance or the same weight. How we are figuring this out is really the same as doing a regular mean, but because a regular mean has equal weights, we can simplify the process. But I just want to show this to you. So let's, for example, say we have two numbers, 84 and 68. Now we're going to just do a normal mean. So again, if you don't know how to do this, watch the video. To do a normal mean, you add the numbers and divide by how many there are. There's two of them. And we would go through this process. We would get 152 divided by 2 equals 76. So the average, or the mean, of these two numbers is 76. When we're doing this, we are actually weighting each of these, but we're weighting them equally. So if we look at this, how we could write this would be 84 divided by 2 plus 68 divided by 2. That's the same as this. These are equal. And then if we break this down further, we really could write this 1/2 times 84 plus 1/2 times 68. These two things are the same. So all these three ways of writing this, they're all the same. You're all going to get the same answer of 76 no matter how you do this. And so, but what you see here is this is called the weight. So here's half and here's half. So each of these numbers, we're weighting them the same. We're weighting each of them 1/2. If we wanted to turn this into a percentage, because a lot of times in the weighted average problems, they'll actually be percentages. Hopefully you know how to write 1/2 as a percentage, and if you don't, you need to watch the video on that. But 1/2 is just 1 divided by 2, and that equals 0.5. A percentage, to write this as a percentage, is 50%. Again, watch the video if you don't know that. But mathematically, we can write 0.5 times 84 plus 0.5 times 68. And if you plug that into your calculator, you're going to get 76. So for a normal mean, just how we've always done this in the past when we haven't thought about weighted averages, a normal mean or a normal average, you add the components up and divide by how many there are. But implicitly what you're doing is you are weighting them, but you're weighting them equally. Here's a 0.5 and there's a 0.5. So each of these components are weighted by 0.5. They have the same weight. When you do a normal mean, all of the numbers have the same weight, and that's why we can take a shortcut and just add them all up and divide by how many there are. When we go to weighted averages, they won't have the same weights. So that won't be 0.5 and 0.5. It might be 0.3 and 0.7. They'll have different weights. And so we're going to do two examples, but I just want to show you how it relates to something you should already know how to do, just the normal average. So I'll take a pause and put a problem up on the board. So here's an example problem for using weighted average. And most of the time your weighted average problems are going to be word problems. So you need to read through it, maybe read through it a couple of times and make sure you understand what they're asking. So here, a student's final grade is based on the following categories. Tests are worth 40%, final exam 25%, quizzes 25%, and homework 10%. A student earned the following scores. In tests, got an 83, final exam a 75, quizzes a 90, homework 100. But all these aren't weighted the same. They don't have equal importance. So your homework is not as important as how you did on the tests. You can see that by the weight. Here, homework is only worth 10%, whereas your tests are worth 40%. So that's what is meant by a weighted average. And so they want us to find what is the final grade. And so these are actually fairly easy questions. And so you really just want to look at the numbers. And all you do is take tests is 40%. So here's where you really need to know how to write a percentage as a decimal, because we can't multiply percentages. We can only multiply decimal numbers. So if you don't know how to do that, you need to watch that video, because I'm not going to really go through it here. 40% is written as 0.4. You take the decimal point and move it to the left 2 spots. So we have tests 40%. So we're going to multiply 0.4 times whatever our test grade was, an 83. And then we're going to add our final exam. Our final exam weight is 25, which we write as 0.25 times our final exam score, which was 75. Plus quizzes. So quizzes were 25%, so 0.25 times our quizzes score, which is 90. Homework is 10%, 0.1 times our homework score, 100. And all you do is literally plug these into your calculator. Remember, you have to do multiplication first before you add. And whatever answer you get is the weighted average. So you should get 33.2 when you multiply 0.4 times 83, plus 18.75, 0.25 times 75, plus 22.5, that's 0.25 times 90, plus 10. When you add all those up, you get 84.45. So that is the final grade for this student. You can see that they did really well on quizzes and homework, but in the end their grade was lower than that. It was only 84.45, even though they got 90 and 100. The reason is because these are weighted lower than the tests. The final exam and the quizzes are the same. So your final score is 84.5. So if you remember back to the beginning of this video when we were talking about regular averages, we saw that you could take the weight times the number, plus the weight times the number, plus the weight times the number, and that is how you get your weighted average. So you just take whatever the weight is times its associated number, plus the weight times the associated number, and then you add them up. We'll do one more example. Here's another word problem. And so these are actually not that difficult of problems. So when you see a word problem, some people just kind of get freaked out and they give up. But really read the problem and read it again and ask, what are they really asking for? Because you don't want to get these questions wrong. They're really not that hard. But don't get worried when you see a bunch of words, because a lot of times those words are just distractors. They're not really part of the problem. Lewis entered a cooking competition. His final scores were calculated by using a weighted average of 75% for taste and 25% for presentation. Lewis received a score of 84 for taste and 68 for presentation. What was his final score? So here's a lot of words, right? But all you really need to know is that you're going to use a weighted average, 75% for taste, 25% for presentation. He got an 84 for taste, 68 for presentation. That's what's important in this problem. And so again, weighted average, what do we do? The weight times the number plus the weight times the number, however many numbers there are. So the weight, 75%, you have to write this as a decimal. Remember, to write it as a decimal, 0.75. So the weight times the number, what did he receive for taste? He got an 84. The weight times the number plus the weight, 25%, which is written 0.25, times the number, 68. So 25% for presentation. What did he get on presentation? He got a 68. And that was it. There's only 2 categories. If there were more, we would continue. But that's it. So all you do, plug that into your calculator. 0.75 times 84 is 63. 0.25 times 68 is 17. You add those 2 numbers up, and you're going to get 80. So his final score is 80. So really, this is a pretty easy problem. The math in this is not difficult. You just need to remember to change the percentages to decimals, multiply the weight times the associated number plus the weight times the associated number. Plug it in your calculator and you get it. If you remember at the beginning of the video, we did this problem where we had 84 and 68, and we calculated just the normal mean, and we got a 76. In a weighted average here, where these aren't equal, right? So taste is more important than presentation, so it has more weight. And so since he had a higher score on taste, the average is increased from what just your normal mean would be. So again, just remember when you see weighted average, the weight times the score plus the weight times the score plus the weight times the score plus the weight times the score, however many numbers that you have.